Alright, so today we will talk about this volume problem sums. Okay, let's discuss this question. Okay, the empty container is made up of two cuboids and a cube. The top of the container is a cube. Water flows into the container from the top to the base at 1.619 liters per minute. What is the height of the water level from the base of the container after 8 minutes? Okay, so let's read the question once more. Highlight, underline important keywords, use the right method and check. Okay, so you have an empty container that is made up of two cuboids and one cube. So a cuboid means that you have at least one of the sides that is not equal to the other two sides. Okay, a cube means all the sides are equal to each other. Okay, the top of the container is a cube. Water flows into the container from the top to the base at 1.619 liters per minute. The question goes, what is the height of the water level from the base of the container after 8 minutes? So what is happening is that you are getting water flowing into the bottom of the container first. Okay, it's filling up this first cuboid, right? Once that is done, water goes into the second cuboid section. So we're going to label it. So this is the first cuboid, second cuboid section, and once the second cuboid section is filled up, the water will then reach the cube. And if you keep running the water without turning off the tap, what may happen eventually is that the water may overflow from this container. Okay, so the question is, after 8 minutes, what is the height of the water from the base? Alright, in order to do that, I need to first find the total volume of water after 8 minutes. So a very simple step for that is take 8 minutes multiplied by 1.619. Okay, let's do that calculation. 8 times 1.619. Okay, we're gonna get an answer of 12.952, and this is in liters. Okay, so that I know that after 8 minutes, this is the volume of water that is actually inside this container. Okay, so where will the water be? Will the water be in part 1 in just the first cuboid, or will it flow into container number 2, which is the second cuboid, or will it flow even further up into number 3? Okay, so the way to check that is to check what is the volume of the first cuboid. Okay, is the volume of the first cuboid more than the volume of water that I have, or is it lesser than that? Okay, if it's lesser than that, if the volume or the space in this cuboid number 1 is lesser than the volume of water that I have, definitely the water will actually occupy the entire of this first cuboid. So I need to first find the volume of my first cuboid first, and that is just 40 times 20 times 8. Alright, so that will give me an answer of 6,400. Now this is where you have to be very mindful, very careful about your unit. So this is in cm cube. Okay, how do I convert this to the same units? You can either use liters or you can use cm cube. So since this question is about height is in cm, okay, let's convert the liters that we had into cm cube. Alright, you need to know your conversions very well. 1 liter is the same as 1000 cubic centimeters. Okay, so if I want to change these liters to cm cube, I just have to multiply by 1003. Okay, so this becomes 12952 cubic centimeters. So if you can see very clearly, the volume of water that you have is actually more than the space for the first cuboid. Okay, so the water will definitely flow over the first cuboid. Okay, so where will it flow? Will it be in the second cuboid? Will it be in the third cube? Let's find out by finding by finding out the second cuboid's volume. Okay, so that can be found by taking 36 times 18 times times 9. Okay, so when we do that, we will get an answer of 5832 cubic centimeters. So when you combine the first two cuboids, okay, the total volume of these two cuboids would just be 6400 plus 5832. That will give us an answer of 12232 cm cube. Again, not enough because we have much, or rather slightly more water than the space in first and second cuboid. The space in the first and second cuboid is 12,232, but the volume of water that I have is slightly more than that. It's 12,952. So there's some extra water that will be pushed up into the cube, which is section number 3 here. Okay, so how much water will end up in this cube number 3 is actually just the difference between the volume of water that I have, subtract away the cuboid number 2 and the cuboid number 1. Okay, so this means it's 12952, subtract away 12232. So let's see what is the volume of water that ends up in your cube. Okay, that is 720 cm cube. So this means that in my cube, okay, in my cube I have 720 cubic centimeters of water. So let's draw the cube out. So this is your section number 3 also. So this is your cube. Okay, and in this cube we have 720 cm cube of water. So this part here is all made up of water. Now the cube's height is 12 centimeters, which means that the length and the breadth is also 12 centimeters. If I want to find what is this height here, okay, all I have to do is to take h is equals to the volume divided by the base area, which is 12 times 12. Okay, so 720 divided by 12 times 12, you will get an answer of 5 centimeters. Let's do a quick check, okay? Let's find the volume of water again. Let's say the height is now 5. Okay, so 12 times 12 times 5, indeed, we will get 720 cubic centimeters. So this means that the height of water for the cube section only, this is 5 cm. But the question is asking, what is the height of the water level from the base? Okay, so I need to take this 5 plus 9, let's use a red color. So 5 cm is for section number 3, 9 cm is for section 2, and 8 cm is for section 1. So 5 plus 9 plus 8, the final answer will be 5. Let's write it down here, 5 plus 9 plus 8. Okay, so that is 14 plus 8, which is 22. Okay, so that is 22 centimeters. So that is the final answer for the height of the water level. Okay, so again for this question number 1, you need to find the total volume of water that is occupying this container after 8 minutes. Number 2, you find the space in the first section and the second section. And in this case, the space in the first and second section is lesser than your volume of water. So the volume of water will actually be pushed up all the way into the third section, which is into the cube. We try to find the volume of water in the cube. From there, we find the height occupied by the water in the cube itself. From there, we add to 9, we add to 8 to find the total height of this water level after 8 minutes. Okay, so there you go. That's how we attempt this volume question. I hope it helps. Thanks.